So we're going to talk about the stabilities of intermediate. Stabilities of intermediates. What are the intermediates? Intermediates are the species that form during the reaction and vanishes before the reaction ends. So first is carbocation. First intermediate is carbocation. Remaining intermediates we're gonna study here like carbon and free radical, but carbon, nitrogen, and benzene we won't be studying here. The stabilities we won't be studying over here. So first of all, we are studying the stability of carbocation. So that is stability comparison. Remember, we have studied the stability in inductive also, in hyperconjugation also, and in resonance also. But here we are studying overall stability. Overall means including all the effects, including all the effects we studied in GOC. So, first of all, which is the most stable carbocation? So, we're gonna write down the order, like which is the most stable carbocation we know exists on the earth. First is CH2 plus cyclopropyl carbocation, which will dissolve like this. It will go here, then it will form this, and it may also go like this, and it will form this. What is happening over here? Why the bond is breaking and it is forming a double bond like this? So first of all, let's study why it is happening like this. In cyclopropyl carbocation, remember that these the bond angle is 60 degree. Bond angle is 60 degree. But actually the bond angle should be 109 degree 28 minute. That should be the actual bond angle. That should be the actual bond angle, right? So there is a strain. Strain is 109 degree 28 minutes minus 60 degree. So it is 49 degree 28 minutes. Means that much strain is occurring in the table. Now we are talking about carbocation over here. So that much strain. So what will happen? This ring will try to break. This ring will try to break. How it will break? It may break like this or it may break like this. So when it is breaking like this, it will form this carbocation because the positive charge will of negative charge and negative positive will form a bond. Or it may form like this. So what will happen? Overall it is forming, it is like this or like this. So what is it is actually we will see these three structures. So this it is looking like it is dancing, right? How it is dancing? First bond breaks, it goes into this, then bond break, it goes into together we see it is like it is forming bond, breaking bond on this side, breaking bond on this side. So this is known as dancing, right? So this is also known as dancing resonance. Or sigma bond is participating sigma bond is taking participate, so it is forming a sigma resonance, dancing resonance or sigma resonance. So what is the most stable carbocation? The structure which has 3 dancing resonance. Cyclopropyl carbocation. Or the structure has 2 dancing resonance. Or the structure has 1 dancing resonance. So this is the most stable, then this, then this. So this is the very first number of stability of carbocation. Which carbocation is the most stable carbocation? Dancing resonance or sigma resonance, cyclopropyl carbocation. If we talk about the second list on the priority, that is part of aromatic system. The carbocation which is the part of aromatic system, here it is carbocation. But this carbocation is the part of aromatic system? No. This is not a part of aromatic system. This carbocation, this is also the part of aromatic system. So these two carbocation are the most stable carbocation. Third is plus M effect. The part of aromatic system. Third is plus M effect. So what is plus M effect? CH3O CH2 plus. So what will happen? This lone pair, it will donate through the plus M, CH3O double bond CH2 plus. Now the third number of carbocation stability is this. Like if I talk about the other example, it is also showing the plus M effect. So it is this. Now next CH2 plus OCH3. So it has lone pair, and after having a lone pair over here, so it is forming, after having a lone pair over resonance, it is forming OCH3 negative over here, and it is forming OCH3 plus and double bond CH2. So that's how it is forming the double bond, right? Now it is also stabilizing. The positive charge is stabilized by the plus M effect. Now we are comparing some questions till we have studied the three order of the plus I effect, stability of carbocation. So very first effect is, let's solve some problems. We have CH2 plus where we have N dimethyl. We have CH2 plus. We have NRR. Here we have NRR. It is showing plus M effect, but it is showing plus I. So plus M dominates over plus I. Second question. CH2 positive. CH2 positive OCH3. Now we know that the more plus M we are getting over here and less plus M we are getting over here, because this lone pair, the lone pair is going in this direction or is on one and on in that direction. So we have 50% resonance going over here, 50% resonance going here. So it is less plus M. Right, why we have written here? It is less plus M. So stability of carbon, and here it is 100% involved. So the resonance is 50% disrupted over here, but here it is 100% involved. Now next question, if we see third question, we have CH2 plus NH2. We have CH2 plus. We have OH. We have CH2 plus. We have Cl. So NH2, OH and Cl. NH2, OH and Cl. So F, O, N and Cl. The most least electronegative is nitrogen and chlorine also. But chlorine minus M dominates. Here plus M dominates. Here plus M dominates. And plus M of NH2 is more than OH because electronegativity of nitrogen is less. So nitrogen has more tendency, so that will be the order. Fourth, CH2 plus NH2. CH2 plus NHC double bond OPH. Fifth, CH2 plus OCH3. CH2 plus OCH3. Now it is 50% involved over here and 50% involved over here. It is 100% involved over here. So obviously plus M is more over here. So this is the, and here it is plus I and it is plus M. So plus M dominates over plus I. So now let's talk about the fourth effect, which is plus H effect. fourth effect in our order, plus H effect. So what is a plus H effect? How it is stabilizing the carbocation? CH3, CH, H and H. So what will happen? This bond will shift over here. CH, H, H positive. Here it is negative charge. CH2 plus. This negative will go here and stabilize the carbocation, and it will form eventually CH, H, H plus. So that's how it is stabilizing. How it is stabilizing? It is forming a positive charge to a neutral molecule. That's why it is stabilizing. We know positive charge is less stable than a neutral molecule. A neutral molecule is always stable than a positive charge because it has an octet complete. So we are talking about stability of carbocation, not the whole molecule. We are talking about the stability of carbocation, only this part of stability we are comparing. Now if I give you some more examples, CH2 plus CH3, CH2 plus CH3. So now CH3, it has plus H and here it is plus I. Second example, CH2 plus CH3, CH2 plus CH2, CH3, CH2 plus and CH2 plus. So this has plus H. How many alpha H? We have 3 alpha H. Plus H. How many alpha H? 2 H. Plus H. How many alpha H? 1. And it is only plus I. So effect or stability on 1, 2, 3, then this. So this is the next plus H effect. Now there is also an isotropic effect. Isotopic effect. So what is the isotopic effect? We have a CH2 plus and CH3. We have a CH2 plus and CD3. We have a CH2 plus and CT3. So we know bond length of CH is more than CD than CT because it is showing plus H. It is showing plus H effect. So bond length and bond strength will be less of that. Bond strength, whenever we are talking about, it is CH, CD and CT. So it is bond strength is more, so plus H will be more. So plus H order will be less because weaker the bond, easily CH will break. So isotopic, this is known as isotopic effect. But if we talk about other type of isotopic effect which do not have plus H, like if we have like C, D, T, then H. So which bond will break first to stabilize the carbocation? We know H will break first. H will break first to stabilizing the carbocation because bond strength is low and it will react first. So it is CH2 plus. If we have another example, CH2 plus, CH3, CH3 and CH3. It is having CH2 plus, CD3, CD3 and CD3. So it is stabilizing the plus I effect. So it is also stabilizing the plus I effect. Now we're talking about plus I effect. CH3, CH2, CH2 plus, CH3, CH2, CH2, CH2 plus. And both have plus H same. So plus I is more in second case. Next is our hybridization. When we have different hybridization, including remaining all the factors same. So how will we define the stability of carbocation? Like CH triple bond C plus, it is sp2, sp, CH plus, it is sp2, CH3, CH2 plus, it is sp2, it is sp3, sp2 carbocation, and it is sp carbocation. Means it was an sp hydrogen which was released. So now we know that it is not actually sp3 carbocation. It is wrong to write sp3, sp2 and sp. We know it is sp2, sp2 and that was sp3. So percentage S character was less, so less electronegative. It is more electronegative, lesser electronegative, or it is least electronegative. Again we have positive and positive. So this is more. Again we have a positive and we have CH2 plus. So again the stability of this will be more. Next is our minus I effect. Minus I effect. So minus I effect, we have CH3, CH2 plus, we have CCl3 and CH2 plus. So it is minus I is more in second case, so stability will be less. All these individual effect we have compared, but now we are writing in that particular order. Carbocation. So stability of this carbocation will more because plus I and it is plus I effect. Minus I and plus I effect. Next is our plus H effect. Minus H effect. Next is our minus H effect. We're gonna write all the effect in and same. Like we have CH2 plus, Cl, Cl and Cl. This will go here and it will go here. Next we have positive charge. Double bond C, Cl, Cl and Cl negative. So and in the end, in the CH2 positive, in the end CH2 positive and here is positive charge, which is repelling each other. Cl, Cl and here we have Cl negative. So these positive charge are repelling. So this is destabilizing or repelling. Next we have CH2 plus CH3, CH2 plus CCl3 and CH2 plus, and here we have CCl3 plus H minus H effect, and it is plus minus I effect. Minus I effect. So it is 1, second stability and third stability. Next we have CH2 plus CCl3. Next we have CH2 plus CH3. So it is showing minus I effect and it is showing plus I effect. So order of the stability more will be more in the case of the stability will be more in case of second. Now what is the next step? Next effect is minus M effect. So why we are writing all these effects? Let me explain you again. We are writing the sequence which is stabilizing the positive charge and which is destabilizing from top to bottom. Next is minus M effect. We have CH2 plus and double bond O and O. And we have over here CH2 plus and double bond O and O. So it is minus I effect and it is minus M effect. So second is more stabilizing, second is less destabilizing, and first is more destabilizing. So that's how we do compare. Next question, we have CH2 plus C double bond OH, CH2 plus CH3, CH2 plus CCl3. So it is showing minus M, it is showing plus H, and it is showing minus H. So this is first, this is second, and this is third. Now next is part of the most least stable carbocation is part of anti-aromatic system. So like this is the part of anti-aromatic system. So what is the overall order we have observed in case of carbocation? The most stable carbocation is first dancing resonance, and the next carbocation is part of aromatic system, and the next one is plus M, and the next one is plus I, and the next one is hybridization. Isotopic effect was also there, but that was in one second. Plus M, then fourth is plus H, and fifth was plus I, and sixth was hybridization. Seventh was minus I, eighth was minus M, eighth was minus H, ninth was minus M, 10th was part of anti-aromatic system. So these all were the part. Like first, the most from it is the most stable carbocation to least stable. So if there were a question where we have plus I effect and minus M effect, we will obviously giving priority to plus I because it is stabilizing. Where minus H and minus M both are destabilizing, but minus HM is less destabilizing, plus M is more. So this will be the answer of the stability of carbocation. So now let's solve overall effect questions. Compare the stability of carbocation. So first is CH2 plus and we have cyanide. Second is CH2 plus, then we have OCH3. Third is CH2 plus, then N dimethyl. Fourth is CH2 plus, then we have chlorine. So it is minus M plus M plus M minus I dominates over here. So answer will be C. Minus M is more in case, plus M is more in case of nitrogen. C, B, then D, then A. That will be the answer. If we name the A, B, C, D. C, then B, then D, then A. We can see the order overall what we have written just. Next we have second. We have over here CH2 plus, then CH3. CH2 plus, then N double bond O and O. Next we have CH2 plus, then CH3. So it is plus H minus M and plus I. So it is 1, 2 and 3. Third, CH2 plus, CH plus, this and this. So this is the first most stable because it is the part of, and this is second because the extent of resonance is more in case of one. Both are the part of aromatic system, but the extent is one more. And third, it is because resonance is going both the side, and this is fourth. So that will be the order of the stability of carbocation. Fourth. This is the more extent of resonance over here, 1, then 2, then here is plus H. Fifth. Is an asked question, I'll give you, just try to solve by your own by pausing the video. Positive charge. So it is stabilizing the by resonance over here and it is stabilizing the plus H. So this is the stable. Sixth. CH2 positive, positive, and here we have positive. So 1 and this is 2 and this is the least stable because part of anti-aromatic system. And let's see the final question. 7th. We have a CH2 plus and this is tertiary butyl group and we have on para CH2 plus, we have this group, CH2 plus, C double bond O H, CH2 plus, O C double bond O H. So it is first, it is second, because it is showing plus M, it is showing minus M, it is showing plus I, it is also showing plus I, but plus I of second is more then first, third, then this will be the fourth. So that's how we are going to remember all the stability by only this effect. How do we compare the stability of overall carbocation? We have to remember this. It is very important. How do we conclude the? This is the conclusion. How do we write? This is the conclusion of the stability of carbocation. How do we conclude the stability of carbocation?